Hello, everybody. I'm Julian Kamaudongo from Kenya. Welcome to PAPERI debate session. I'm from Group 2. My discussion topic was should genetic engineering be used to create universal vaccines? The subtitle itself was genetic engineering should be used to create universal vaccines. I'm on the affirmative team, and my group team member was Yonli Yeboanil Emil from Burkina. So, introduction to it. So, what do we understand by the term genetic engineering? This is the direct manipulation of an organism's DNA to achieve desirable traits. Universal vaccines are vaccines designed to provide broad protection against multiple strains or variants of vaccines, for example, all flus and on coronavirus. So for context, traditional vaccines often lagged behind fast evolving viruses, for example, the flu and COVID-19 variants. Genetic engineering offers tools to create vaccines that are broad spectrum, long lasting, as well as adaptive. Genetic engineering should be used to create universal vaccines because it can revolutionize public health by providing broad, long term protection against deadly and rapid mutating diseases. Okay, so imagine a world where one vaccine protects you for life against every deadly virus. Well, that world is well within our reach with genetic engineering. Genetic engineering is not just a specific opportunity from science. It is a moral imperative to proactively safeguard global populations from pandemics as well as entire diseases. So, our stand as the affirmative team, we strongly support using genetic engineering to develop universal vaccines given the unparalleled benefits in global disease prevention, healthcare equity, and pandemic preparedness. So our constructive arguments were as follows. Number one, genetic engineering enhances vaccine effectiveness. Traditional vaccines often targeted only one or a few viral strains. Genetic engineering allows us to design vaccines targeting conserved regions of viruses, parts that don't change much even as viruses mutate. For example, research into universal flu vaccines uses engineered antigens from the stable chain. The second constructive point we came across was speed and flexibility in responding to emerging threats. Genetic platforms like mRNA vaccines, which is a product of genetic engineering, allows for rapid design, production, and adjustment of vaccines. Potential to quick counter new outbreaks, preventing widespread transmission is well possible while we design this these vaccines was that global health equity. By this we mean universal vaccines could eliminate the yearly need for updated shots like annual flu shots, reducing healthcare burdens, especially in low resources countries. A single widely available vaccine could as well protect billions. Our fourth constructive argument was scientific precedence and feasibility. Success of engineered COVID-19 vaccines like the Pfizer, BioNTech, and Moderna vaccines show that genetic engineering is safe, effective, and scalable. Current trials from the NIH and biotech companies are already working on genetic engineered universal vaccines for flu, coronavirus, as well as HIV. Our fifth constructive argument was about ethical responsibility. If we have the technology to save millions of lives and prevent suffering, not using it will be irresponsible of us. Genetic engineering gives humanity a critical tool to outpace pandemics, thus saving lives across all generations, which is of course an ethical thing to do as human beings who are well underway with science development. So for a rebuttal, the opposing team, the negative team, rebutted and claimed that genetic engineering is risky and unnatural. But we rebutted their claims and said all vaccines manipulate biology, engineering improves precision, safety, and reduces unintended consequences compared to older methods. The opposition team claimed that long-term effects of the vaccines are unknown, but we rebut and say rigorous testing ensures safety. mRNA vaccines show that genetically designed vaccines can be safe and effective too. The opposition claimed that it could be expensive and inaccessible to create these vaccines, but we rebut their claims and say engineering can lower production costs long term. Universal vaccines will reduce the need for multiple vaccines, therefore saving money in the overall run. The opposition claimed that ethical concerns about tampering with nature, but we rebut their claims and say that ethics demands saving lives. Using our knowledge to prevent suffering is the highest ethical obligation we have as scientists. So for our closing statement, the summary of everything that we researched was that genetic engineering offers a scientifically sound, ethically responsible, and globally impactful method to create universal vaccines. In a world threatened by evolving pathogens, inaction is the true danger. Genetic engineering is the proactive solution we urgently need. For our question and answer section, these are the most common asked questions and their smart responses. So we might be asked, how can we be sure universal vaccines will work? Well, our answer is universal vaccines target the most stable parts of the viruses. Current research shows strong potential in this. What about mutations we can't? Well, genetic platforms are flexible and can adapt much faster than traditional methods. Another question we might encounter is it ethical to engineer parts of viruses? And well, yes, engineering ensures we create the safest, most targeted immune responses without causing any diseases whatsoever. Another question is, won't rich countries get vaccines first? Universal vaccines aim to eliminate inequality by requiring fewer doses, therefore benefiting everyone globally. So for our bibliography and the reference part, these are the places where we got our references from. Centers for Diseases Control and Prevention, the CDC, the National Institutes of Health, World Health Organization, as well as Pfizer Biotech and Moderna Inc. Thank you very much. That's the end of it. Thank you. It was an honor presenting this. Have a wonderful day. Thank you very much.